In this problem, we are asked to define a function named getCallMax. So again, I'll just start. I don't even have to think about what the function's doing to just get myself ready for it. It takes two parameters, a nested list and an integer j. Okay, so I'll call my nested list L. It looks like in the example here they called it L. And j, because I don't know, that's what they said. And it'll make me less confused if I keep it the same name as it is in the example. This is supposed to return the maximum of all the elements in column J. So these two-dimensional lists are organized as like a list of rows. So column J. So in this example, L1, it returns 9 because column 1 has the elements 7, 2, 9, 5. 7, 2, 9, 5. And of those numbers, 9 is the largest. So there's a couple ways I could do this. I could figure out how to iterate over just these elements and do the max finding pattern. So I'll do that way first, right? I need to have a for loop that iterates over just those elements. Now here, because I want to index, this would be index 0, 1, 2. I'm always looking in a list and pulling out index 1. Looking in the next list, pulling out index 1. Looking in the next list and pulling out index 1. I'm going to do the iterating over the indices pattern just to try it because it looks like indices are helpful. Okay, so I'm going to write that loop first, and then I'll build the max finding pattern around it. So if I do the iterating over the indices solution for iterating over L, I'm iterating over like IDX, my index. For index in, I'm using range because that's going to generate a set of numbers. And the set of numbers I want to generate are not the 0, 1, 2, because I'm not iterating over the 0, 1, 2. In fact, this is numbers just given to me. The reason I'm always looking at 1 is that's the j. But I am iterating over this, list by list by list by list. And L has 4 things in it. Right, that's the blue. There's 4 of those blue things. It just happens that they themselves are lists. So if I do for IDX in range len L, IDX will take the values 0, 1, 2, 3. And that will let me get each of those lists. Right, each of those lists are Li. This is L0 is this blue thing. L1 is this blue thing. L2 is this blue thing. L3 is this blue thing. So the thing of interest to me, this element of interest to me is really L IDX That picks out the particular row I care about. And then if I index into element J, that gives me the first time through this loop, the 7. The next time through this loop, the 2. The next time through this loop, the 9. So this is the element I care about. Those are the things I want to figure out the max of. So this is where that pattern where I say like the biggest thing I found so far, if the element is greater than the biggest thing, then it's the new biggest thing. And then at the end of this function, I'm supposed to return the biggest thing. So that would be outside the loop after I've looked at each of the elements. I'd return biggest. I'd have to figure out how to initialize biggest. There are lots of choices. I could initialize biggest to something very, very, very small, like that negative infinity. Or I could just initialize the element to like the very first thing I'd want to consider. That in the example, it's like that's 7. So I could just initialize it as like L0I or L0J to say, hey, I'll initialize it to 7. The first time through the loop, I would say, oh, I found a 7. 7 is not bigger than 7, so I don't do the if. The next time through the loop, it's a 2. 2 is not bigger than 7, so I go through the loop. The next time I see if find a 9, well, 9 is bigger than 7, so that's the new biggest. So this works, but I could have equally done the like infinity solution, the like float inf, or no, negative infinity. I'd want something very, very small to initialize it as, so it immediately gets kicked out. So here's one possible solution. I want to do a couple solutions. So I could have also done my list builder pattern. Like, what would that have been like? And because I could have said, oh, let's just build up the list. I'm just going to call it column, because I could just pick out the elements of the column that I care about. And then I could say for IDX in range L len, sorry. I could just do column dot append. L IDX J. And then to return the max, I could use the max function of call. Right, I'll just build up a list of all the elements I care about, and then I can use max to figure out what the max was, as opposed to using that max finding pattern. I could also loop over the elements rather than looping over the indices, because the elements in this nested list are lists. So I could say, let's loop over them individually. Oops. And this is where I have to pick a variable name. And my favorite variable name for lists is being used already. So I guess I'm going to use a little x, like for x in L. Now remember, because L is a list of lists, X is itself a list. The first time through, that X is going to be the blue list that is 5, 7, 10. The next time through, it's going to be the next blue list that's 3, 2, 1. So the things I want out of that list would be the elements that I put in this column list. I'm appending X, which is a list, at index J.